Hi, this is Troy Davison, creator of the PHRETS library. So let's talk about the changes and the features you can see here in the second major version of the library. The first item is a change of requirements. The newest version requires PHP 5.4 or newer. PHP 5.3 was released in June of 2009 and it reached end of life in August of 2014. And so as the PHP community in general has moved to more modern versions of PHP that include bug fixes and various other improvements, this library is basically going along with that. So PHP 5.4 or greater is now required. Item number 2 is a greater use of Composer. Composer manages a lot of the dependencies and the downloading and updating and auto-loading of those dependencies for us, so it makes integration with other outside packages a lot easier. And the major package difference that you'll see with version 2.0 is a new dependency on Guzzle. Guzzle replaces all of the manual curl interactions that were happening in the version previously. So Guzzle handles all of the setting of HTTP headers, making the requests, parsing the responses, and making it much easier to recover from errors and understand what's going on. Another package difference is now the introduction of some Illuminate packages from the popular Laravel framework. Those packages allow for the easier use and interaction with arrays or with previously loaded objects, and we'll get into that a little bit later. The third item is that version 2 is much more object-oriented, where previously the first version of the PHRETS library was basically one file and one class. This new version is divided up into various classes that each have their own individual responsibility. And those classes now interact with each other in order to take advantage of those different responsibilities. So for example, a configuration object is configured with the connection details to connect to a Rets server. That's then passed to a session object, which is what's actually responsible for orchestrating the requests and the responses. And then when those responses come back, those responses are handed off to individual parsers in order to determine the best way to handle those responses and to pull the necessary information out of those. Also, with it being more object-oriented, where the previous version used really old die commands or had kind of a clumsy way of doing error checking, the new version will throw many more exceptions in cases where there are unrecoverable errors, whether that's from Guzzle, the underlying HTTP library, or if there are conditions that the PHRETS library itself recognizes are unrecoverable. It will throw those exceptions that will allow those to be caught and handled in any way that's appropriate for your particular application. Number 4 is an easier configuration because of fewer configuration options. And this is possible because of better compatibility with the Rets specification in general, both on the PHRETS side and with Rets servers in general. The original version was created many years ago, back in 2006 or 2007. And at that time, the compliance and compatibility of different Rets servers was pretty different. The landscape of features and how closely people were adhering to the Rets specification was much different from how it is now. And so, for example, the parameter option to force user agent authentication is no longer needed. Compression is enabled by default through Guzzle, and Guzzle will handle interacting with servers that do or don't support compression. It will handle that on its own. In addition to that, a few configuration options existed before for debugging, and the way that debugging works with this newest version is slightly changed. And that brings us into number 5, which is now built-in logging. The built-in logging is made possible through being made compatible with PSR3 loggers. PSR3 is basically a suggested standard that has been developed by the Framework Interoperability Group. PSR3 basically defines an interface, an object interface for different output messages of different levels. So for example, you can report different messages in different contexts to different output levels. Debug, info, notice, warning, error, critical, alert, and emergency are all the different levels that are supported. So for example, you might log that a request is being made to a server at a debug level. However, if there are errors that come back, that might be considered a warning or an error, or in some cases a critical. With those PSR3 loggers, you're then able to handle those different conditions in a way that's appropriate for your particular application. So there'll be a separate video that will discuss in detail and give some examples of what that actually looks like. but that is a major change in the way that debugging works with this newest version. Item number 6 is support for the Rets 1.8 specification. There were a number of changes and new attributes and new HTTP headers that were introduced with Rets 1.8. The previous library supported some of those already, but this newest version is now able to connect to Rets 1.8 servers to parse the changed format of those 1.8 responses. It can see the additional metadata attributes, and it can see the additional get object headers and other sorts of modifications supported by the 1.8 specification. Item number 7 deals with strategies, and there'll be a separate video that will start to dive into specifically what this means and the ways to interact with this specifically. But strategies basically provide extension points within the PHRETS library, where with the previous version of the library there was only one way to handle certain things. The newest version supports these various extension points for strategies. One example of that is the way that records are automatically paginated by the library. Different servers have slightly different ways of interpreting some phrases within the Rets specification, and so in some cases it is necessary to slightly tweak the way that the library is determining how it's paginating, when it should paginate, how many records to pull at any particular point in time. So what these strategies allow for is you to provide the logic that's necessary in order to modify the behavior in some of these cases. Another example is the login parser. When you connect to a Rets 1.8 server, the strategy for connecting to a Rets 1.8 server will determine that it needs to use a parser that's capable of understanding a Rets 1.8 response. And so it determines through the strategy which parser to use for those login responses. And so the library is much more flexible and much more extensible by supporting those strategies. So like I said, there'll be a separate video that will talk about the different options there, and we'll give some examples of some of the flexibility and power that provides. Number 8 is better testing. With the previous version of the PHRETS library, there were no tests necessarily that were done. All of the testing and all the bug fixing required manual interactions and manual tries from those running into issues to see if the problem was fixed through some code change attempts. This newest version makes use of PHP-Unit for unit testing, which tests individual components. With the third item that I mentioned, where PHRETS is much more object-oriented, things are divided up into individual responsibilities, and so PHP-Unit is able to much better test those individual components and determine that they are doing what they are intended to do. In addition to being able to test individual components, we're also making use of a Guzzle Recorder plugin. And what this plugin allows us to do is, as we are interacting with Rets servers in a test and in development environment, we can set the recorder to record a request being made and the response that's returned from that real server, so that in the future when we make that same request through Guzzle will not need to actually make a connection to that Rets server. Instead, it will simply replay the response out of a text file that it received at the time that it made the recording. What this allows us to do is to do fuller testing of the entire life cycle and the entire session, so that we can basically make a fake login response, and as far as the PHRETS library is concerned, it believes that it's actually connecting to a real Rets server. However, no connection is actually made. So those responses from real servers are helpful so that we can test that parsers are acting correctly and that the various strategies are being performed correctly. In addition to that, it allows us to modify responses to exhibit behaviors that we have not seen in servers that we have access to. There are a lot of different Rets servers and a lot of different implementations for things. And so by taking a recording from one server, we can go in and actually manually modify and tweak the response that was recorded to exhibit a slightly different behavior, and then we can write our unit tests against that different behavior and verify that it is working under those circumstances. So that's a very powerful feature that allows us to determine that the library itself is doing and understanding responses the way that it should be without actually requiring connections to various Rets servers. Along with PHP-Unit is the introduction of support for the Travis CI system for the continuous integration. Basically, any code push that's pushed to GitHub or any pull request that's made will automatically end up with all of the unit tests that have been submitted to be reran over the entire library. That allows us to determine if any new bugs have been introduced or if any change that's being proposed actually ends up breaking existing functionality. All of the functionality is verified against PHP 5.4, 5.5, 5.6, and HHVM, and as new versions of PHP are added, that this library will support, those will be added as well. So with a system that automatically runs tests and with a system that supports tests in general, we can talk about code coverage. Previously, as I mentioned, the first version of the PHRETS library had no tests, and so there was no automated way to determine that the library was doing what it needed to. Now with unit tests, and now with a continuous integration system which can run those unit tests and verify that things are working appropriately, we have a way to continue to verify that the library is doing what it does. At the time of this recording, version 2 is at 100% code coverage with the various unit tests that are supported. And as future changes are made, more unit tests will be added to verify those additional capabilities, and those tests will continue to run to verify that changes aren't breaking anything previously coded. So that's a brief rundown of the 8 major changes and features that you can expect with version 2.0. So that's it for this video. If you have any comments or suggestions for future videos or things that you'd like to see covered, please leave those in the comments below, and enjoy version 2.